This is an orthokeratology case where the patient is slightly undercorrected after treatment and also has some residual astigmatic prescription that's coming through the post-wear refraction. If we look at the post-wear topographies, getting pretty good centration of both lenses, and let's go ahead and bring those up. So these are the lenses that the patient's wearing right now, and we're in RSIM mode. We're getting a little bit of clearance, but getting pretty good centration in the post-wear topos, and so I think RSIM would work just fine, and leave it in that mode. An interesting thing with this patient is, let me bring up the pre-wear topography. Here, if we look at the Ks, they're fairly spherical. A little bit of against rule cylinder in the right eye and a little bit of oblique cylinder in the left eye. And if we look at the patient's refraction, there's quite a bit of cylinder and refraction, 2 diopters in the right and a diopter and a half in the left. So this tells me the patient has some internal against the rule astigmatism. And if we click on the over-refraction button, we'll see that WAVE actually predicts after or with a spherical lens or correction, the patient's going to have about a diopter and a half remaining cylinder in the right eye and a diopter in the left eye. So the residual cylinder you're getting right now in your posterior refraction is kind of normal, I think, for this patient because we're not changing anything, obviously, at the lens. So a couple options with this patient. One is to increase the demand of the lens so that the patient still has the remaining diopter or so of residual astigmatism, and maybe we can do an EDS of plano. So we'll aim for a post-wear refraction of plus 50 minus 1 as opposed to minus 50 minus 1 as it is now. The other thing you can try is molding cylinder into the cornea, which is kind of difficult. Molding cylinder out of the cornea, a very toric cornea, is possible. It's not very easy. Molding cylinder into the cornea to counteract any internal astigmatism is probably even harder. So if you hold up some minus sphere trial lenses and the patient is pretty happy at plus 50 minus 1 or plus 75 minus 1, I think that target would be easier to get to. And I'll show you how I would do that. It's pretty basic. If we want another diopter, then I would just increase the demand so that we're about plus 2.25 or 2.26 or so in 100% mode here. So we're just going to increase demand until we're at right around 2.25. We're in RSIM, so it should be pretty stable throughout every meridian, and it is. Okay, so we've got increased demand. This will mold the cornea a little bit more and hopefully get the patient into the plus side of the spherical post-wear refraction. The cylinder that you're getting in the refraction will still be there because we haven't done anything to change that. As far as molding with the rule astigmatism into the cornea to kind of counteract what is behind the cornea, I guess theoretically you could go to an oval optic zone in the horizontal meridian, and then if we have a diopter or so of astigmatism, then we want the differential between the two powers to be a diopter. So for plus 1.18 right now, let me bump that. I think we were a little bit under minus. I'm going to pause the video and see what the correction was. Okay, so the post-wear refraction for the left eye was minus 75, minus 1. So as a whole, I would bump this 75, so that'll put us around 193. This is going to be in 100% mode. We'll undershoot a little bit. And then for a toric optic zone, we do have to go to a GSIM lens. We can't change the horizontal meridian independent of the vertical meridian in an RSIM lens. So I'm going to switch to GSIM. And then in 50% mode, Right now you're at 6.2 and 6.8, so I'm going to reduce this to 5.6 and 6.2, and this will be in the horizontal meridian. 5.6. And 6.2. And now you can see our vertical oval, where horizontally we have a smaller zone, vertically we have the same treatment zone as before, and then the oblique meridians are in between. Now we want there to be about a diopter difference, and we're right about there. So 1.92, we want the horizontal to be about 2.92. So still in 50%, I'm going to just bump this up a couple clicks, or maybe just one click, and we're there. So now we have a shortened optic zone in the horizontal meridian with a diopter more demand than the vertical. Another thing I would do with toric optic zones in 100% mode, again, I'm going to get the periphery to bear down a little bit more and make sure we're getting really good seal off in the periphery. And you know what? I see a funny kink in the graph there. I'm going to try to get rid of that. That's good. Okay, so here we have a zone, or an optic zone for the left eye. Again, this is kind of a theoretical thing. I'm not sure I'd really recommend trying it unless the patient was absolutely motivated and knew that there is a fair chance that the results may not be exactly stellar. But you could technically mold cylinder into the cornea, and that would hopefully get rid of some of that internal or counteract some of that internal astigmatism. I think the best bet is to try to get the patient closer to a plano EDS, and possibly that will be good enough for vision. So thanks for watching the video. Hope this helps your patient, and goodbye.